All righty. Today, we're in social studies. We're going to work on bringing together text and visual data. All right. So let me find the lesson here. Uh, we haven't looked at a lot of, visual data yet. We've seen a few charts, some tables, of information. I think we actually saw some in language arts. But we're actually going to get to some maps today. And so Okay, there it is. Yeah, so like it says, bringing together text and visual data. So when it comes to visual data, a lot of times that's going to be used as evidence, right? So somebody is trying to make an argument about something or describing something, giving information about something, and they include visual data to help. It's going to enhance what they're saying. It's going to clarify what they're saying, just like supporting details will. And that's the way a lot of times that we're going to look at that data. If it's used as evidence, right, you're going to evaluate it in much the same way that you would other types of evidence. Is it relevant to what the person's saying? Does it actually support the argument they're making, or claim that they're making? So we'll go ahead. We're going to jump right in here.
Hi, this is the lesson about bringing together text and visual data. When you read a social studies text, you'll often need to compare it to charts, graphs, and images. This lesson will help you do that.
Now, in social studies in particular is where you're going to see, visual data. But don't be surprised in language arts, if they throw a table of information at you in your test, or either a table of information or maybe even some numerical information from time to time. But certainly in social studies, maps, charts, graphs, different types of tables, that's all fair game.
Social studies includes a whole bunch of different topics, everything from government to economics to geography. Some of those topics are too complicated to talk about with just text, so you're also going to see stuff like charts, graphs, and diagrams. You may find some of it confusing, but trust me, it's all there to help you. The other day, my mother admitted to me that she and Dad are having trouble paying their medical bills. My parents are American citizens now, and they both assumed that life would be easier here in the US. Mom seemed pretty embarrassed that she was struggling so much, so I tried to explain to her that she isn't alone. Many Americans struggle to pay for health care. It's one of the challenges we face as a nation. I even showed my mom an article about the correlation between income inequality and poor health outcomes. Basically, the article explained that the more income inequality a country has, the less healthy its citizens tend to be. It summed up its findings with a chart that compared 20 of the wealthiest countries in the world. Here it is. As you can see, the United States has the highest inequality of all 20 nations and the poorest health and social outcomes. My mother took one look at this chart, pointed to the y-axis, that's the part over here on the side, and asked, "What counts as a health and social problem, Maria? That isn't a number you can measure. What is this chart measuring?" My mom is as sharp as ever. You see, charts usually use quantitative data, but this one is using qualitative data. What's the difference? Glad you asked. That's the first thing I want to talk about.
Yeah, qualitative versus quantitative. So, we'll get some definitions here. This is an important step here. So, yeah, so something like this, income inequality and health. So visualizing that information, Mariama, we're working in on bringing together text and visual data. So we just got started. Income inequality and health, right? So So first off, same thing, maps, charts, text, right? You read the title, right? You got to know what's being presented here and understanding the information that's being presented. So just like it says here, income inequality and health, right? A causal view, right? We talked about causation and correlation, right? And something like this with a graph. Your y-axis along the side, right? You got to make sure you understand that. So index of health and social problems. And then across the bottom, income inequality. So those that have lower income inequality, right? There's a correlation here between health and social problems and income inequality. So you see the United States way up there, right? It's the worst as far as health and social problems, and it has the highest income inequality, right? So income inequality meaning that you have, you have these like super stupid rich people, the elite, right? We hear about this quite a bit, and then you have, people super high amount of low income people, right? People that are living below the poverty line or at the poverty line. And then it's tracking, right? So we see a correlation between those two. It's pretty good in Norway, though.
Okay, don't make fun of me, but this is my old student ID. Why can't they ever get a decent picture of me? Anyway, this identification has examples of both kinds of data that I want to talk about: quantitative and qualitative. Quantitative data includes things that you count or measure. So height, weight, temperature, and time are all good examples of quantitative data. Quantitative data quantifies something. If it's a number, it's likely quantitative data. This is usually the kind of data you see in charts, graphs, and spreadsheets. So let's see what kind of quantitative data we have here. Well, there's the expiration date. That's a date, a number. What about my identification number here? Yep, that's quantitative data too. I'll circle both in orange. Qualitative data is a little different. Qualitative data is a descriptive word or phrase, data that tells you about a quality that something has. Sometimes qualitative data will evaluate something without resorting to numbers, kind of like a letter grade on a report card. You'll see a lot of qualitative data in the social sciences. So let's see here. Yep, there's all kinds of qualitative data on this ID. There's my name. There's also my sex, eye color, and status. There's all kinds of qualitative data here. I'll circle them in blue. Sometimes qualitative data will be based on quantitative data because the qualitative data is summing up quantitative data. I mentioned how letter grades are qualitative, right? Well, think about the number of quiz and test scores it took to earn that letter grade. They were all quantitative, but they came together for one final qualitative letter grade. Something to keep in mind. Pretty straightforward, right?
Right, so quantitative, right? Quantities. Rachel is your quantitative teacher, right? So things that deal with numbers. Qualitative, things that kind of deal with letters and words. So I'm your qualitative teacher, she's your quantitative teacher. In academia, I mentioned I work for this policy research institute. We were talking about writing our dissertations, right? Our big final projects to get our doctorates, and dealing with engineers and mathematicians and, that type, the science and STEM fields. They were talking about, my dissertation is, 125 pages. And I was like, oh, wow. I was like, mine's 450, right? Because a lot of their dissertation, a lot of their pages are actually going to be numbers, right? They're going to have a lot of graphs, they're going to have charts, they're going to have numerical information. Not that they didn't work really hard on their research and everything, but for me, it's history, right? And the only way, well, I mean, you could certainly put some charts and there's other types of data, but it's generally going to be a lot more words. So it's going to be that qualitative type of data.
Which of the following answers only uses qualitative data?
Okay, yeah, so we're looking for qualitative. So what only has qualitative information or data here? Let's see, Jessica, you want to give that one a try? I'm not sure, Jessica, I can't hear you if you've said anything. I'm not sure.
Sorry.
That's all right.
I was in, but my headphones don't have the mic part.
Oh,
So I just sat there, read all the answers, and thought I was talking to you guys.
that's fine. So one there.
So we're just reading them. I'm gonna go with C.
So it's A. Okay, so first thing, one thing you can always think of, right? Do you see numbers? Right? If you actually see like physical numbers, that's probably going to be quantitative data, right? So qualitative, basically text-based, word-based. So if you look at number one, right, since Amanda received an unsatisfactory review on her final essay, she earned a poor course grade. So all of that's qualitative, right? It's all text-based. And see, here's the thing, in a lot of circumstances, it's going to be best to have both types of data, right? Because qualitative sometimes can be subjective. What exactly is unsatisfactory mean? What does poor course grade mean, right? If you include quantitative data with that, right? If you have numbers, that helps clarify things sometimes. And that's the other thing too, right? If you just have a bunch of numbers, sometimes that's difficult information to try to wade through. So if you have somebody offering qualitative data alongside of it with some explanation of the table or chart or graph, whatever you're seeing, that's going to help as well. So they work well together, right? And sometimes it really helps strengthen what you're reading if you have them. And that's kind of the idea here, right? If you have both visual information and you have text information, that together can really help explain things.
Great job.
Show you
That's right. Unsatisfactory isn't a numeric value. It just describes Amanda's general performance on the essay. Similarly, earning a poor grade isn't quantitative because poor has no numeric value. All the data in this answer choice is qualitative.
Yeah, so exactly, right? And let's say you were a student and somebody said, well, your work is unsatisfactory, right? You would want a little more explanation. You might want your teacher to show you some numbers or something to help explain that.
Visual data can be related to text in a few different ways. It's your job to understand the relationship. Sometimes visual data can extend the information in the text. That means it gives more information on the topic. If you're reading about the stock market crash of 1929, for example, the text might extend its meaning with newspaper headlines reporting on the crash. Or it might include a line graph showing the plummeting Dow Jones Industrial Average. The visual data in this case would give you a better understanding of the 1929 market crash. What happened, when it happened, and how people responded to what happened. Visual data can also clarify what's in a text. making it easier to understand. You might read a story about the extreme poverty in Madagascar, for example. The text might tell you that life is difficult there, and it might tell you that many Madagascar citizens live on $1 a day or less. But like they say, an image is worth 1,000 words. Photos from Madagascar can show you firsthand how people live and some of the challenges they face. Visual data can give you a better understanding of what the text is trying to tell you. Think you got this? See if you can identify how visual data might extend or clarify a text.
Yeah, so that's the thing, right? It doesn't even have to be just charts, graphs, maps, whatever, photographs, diagrams, right? An illustration, exploded view of something like, like instructions, right? Those have a mix of visual, information, data, and a lot of times, text as well. If you're putting together, a couch or anything, if there's instructions there, they might have some simple sort of text, and then they'll actually show you, how things go together. But yeah, even photographs, that's good visual data.
Does the visual data extend the text, clarify the text, or both?
Okay, let's take a look here. All right, so violence, health, and income inequality. So for many decades, independent studies have looked at the relationship between income inequality and health. Many of these studies saw a correlation between income inequality, infant mortality, and reduced life expectancy. In 1993, public health researchers compared 34 of these independent studies. They concluded that income inequality was a strong predictor of societal violence. By the late 1990s, social scientists had combined their research with the work of public health researchers. The two areas of scientific study overwhelmingly agreed that income inequality was a strong predictor of poor health and social problems. Researchers combined their data on income inequality with their data on health and social problems to show how different countries compare to one another. The researchers defined income inequality by comparing the ratio of wealth between the richest and the poorest people of society, right? So that's what I'm talking about, income inequality. If you got a high group of your, of people living at the poverty level, and you have a high group of people that are, stupid rich, those, that's your income inequality, and you have less of a middle class. The United States used to be well known for a very strong middle class, particularly through like the 1950s and 1960s, like after World War II. That really helped drive, our economic success in that time. And that has started to deteriorate, right? So we're kind of pulling away into each side, and there's less of that strong middle class that we used to have. To calculate the index of health and social problems, researchers combined data on a variety of health-related subjects, including life expectancy, mental illness, obesity, infant mortality, teen births, homicides, imprisonment, education, distrust, and social mobility. Researchers concluded that income inequality worsened the health outcomes of people with low socioeconomic status. And there again is that same graph they showed before. So, like before, we look at the title, we make sure that we understand what's going on there. And then on both axes, going up the side and across the bottom, income inequality from low to high, right? So, and then index of health and social problems. And so we see, across the board there, Japan, the lowest income inequality, super strong sort of upper middle class population there, middle class population, and, low health and social problems. We don't hear, a lot about riots and crazy things going on in Japan. So a very stable sort of society and community. It's a bit closed. It's a very homogenous nation. there's certainly, foreigners that live there. There's people that immigrate to Japan, but, very kind of homogenous society there. Norway, Sweden, Finland, all these, particularly like Northern European countries, also, low income inequality and low health and social problems. And then you start kind of climbing the ladder there. You get about halfway up to Canada, France, you start seeing some issues. And then way up at the top, you got the United Kingdom, Portugal, and then USA is like this outlier. It's so bad. It doesn't even really track with everything else. We're way up here as far as income inequality and health and social problems. Okay, and our question, does the visual data extend the text, clarify the text, or both? So it clarifies and extends, okay? So it both, right? It clarifies the relationship and extends the text by showing how countries compare, right? It's one thing to say it, it's something else to show it. And by giving that information, you get both there.
Great job! The graph provides more information than the text alone, so it does seem to be extending the text. It also makes it easier to see the relationship between inequality and poor social and health outcomes. You can see that the two values increase together. This visually clarifies the relationship.
And what social scientists do, what other fields do, is look at those kind of correlations, and that's where you start getting more in-depth studies, right? Why is it that if you have these sort of economic we know like in your lower income communities, you tend to have more crime, you tend to have more drug issues, drug related crime, things like that. And that's where people really dig deep and see why those things are happening.
Visual data can also be used to support an argument, and not just an argument in a text. Let me give you an example. Last year, Octavio and I had a disagreement about whether violent crime had gotten better or worse in the US. I thought it had gotten worse, but Octavio was convinced that violent crime had gotten better overall, just not in our neighborhood. We went round and round on this topic. He said one thing, I said another. He was sure he was right, but so was I. Eventually, Octavio found this graph showing the violent crime rate in the United States. The graph is from the FBI. As you can see, according to the graph, violent crime has been going down for the better part of 20 years. This supports the argument that violent crime has been decreasing in the US. You want to be careful, though. Sometimes statistics can be misleading. Always make sure that the data you're looking at is relevant to the argument it's supposed to support. If this data was for only one state, or if it included information for only one kind of violent crime, it wouldn't support a general statement about violent crime in the US. But this graph does support Octavio's argument perfectly. Sometimes visual data might contradict an argument, that is, it might go against the argument it's trying to make. Last year, I read an article about my city's budgetary spending. According to the article, our spending had increased every year for the last 5 years. But look here. This was a graphic included in the article. Look at 2014. In 2014, our spending actually went down. While it's true that the city's spending has been trending upward, it's not true that our spending has increased every year. This is a case where the visual data contradicts what the text is saying. Well, that's the basics. Let's see if you can spot when visual data supports or contradicts a text.
Right. That's the thing, too, is you have to have a good eye. And as she mentioned, does it encompass exactly what, just like we're talking about in text and everything, does it speak directly to what they're trying to argue or the claim that they're making? And that's the thing with visual data. Sometimes it gets a little tricky. You have to make sure that in this case, right, specifically every year. No, that's not the case. It did not increase every year. And statistics, can be sort of massaged, right? They can kind of be manipulated. And it's great when you have a lot of information because that will help you decide, right? If somebody just tells you an average of something, that might not tell you everything you need to know, or, something like this. So the more information you have, always, the better off you'll be.
How does the included map support or contradict the information in the text?
Okay, and so the nation's median age continues to rise. Have you all got around in math of talking about median, mean, range, and mode? Those ideas, sort of like statistical ideas?
No.
Okay, so all right, I'll give you a primer. When it comes up in math, you guys will be ready to go. You'll impress Rachel. So mean, right? You're familiar with mean? It's an average, right? So you got a column of numbers. You add up those numbers, and then you divide by how many numbers that you have, right? How many entries do you have? So if I have like 3 numbers, and I add them together, I divide by 3, right? That's my average. Mean is average. Median, what we're talking about here, is the middle number. So just like the median on the highway, right? It's in the middle of the highway, like separating your inbound and outbound traffic. Median is the middle number. Range, just like it says, is the range of numbers. Okay, and then there's mode, which, if you have a whole data set, is the number that appears most often. Okay, just a quick example, right? Say, I have a class, history class I'm teaching. I got like 50 students. We take an exam. All right, do all the scores. I have my lowest score for a student is like 59. My highest score for that student is 100. So that's my range, right? Lowest score 59, highest score 100. The average, just depends on where everybody fell. But I would add, I take all the scores, I take those 50 scores, add them all up, divide by 50, and that would be the average score for the exam, right? The median would be whatever falls right there between 59 and 100. So, if somebody scored around like a 79 or 80, I think falls right there sort of in the middle, right? That's a median. And then the mode would be, the score that, occurred the most. So if I had like 5 students that got an 84, right, on the exam, that would be the mode, and nobody else, that was the most common score, right? That would be the mode. So that's what I'm talking about. If you have that much data, right, it tells you a lot more than any individual one of those numbers, right? If I know where the middle number is, if I know what the range of numbers are, if I know what the average is, if I know which number occurs the most, that gives you a lot more data. But a lot of times we'll hear things about mean, the average, or the median, which is the middle. So here, the nation's median age continues to rise, right? So where everybody is in the middle, right? We have 0, right, is basically the youngest age, and whatever the range is now, 105 or however old, the oldest American is. And so the median is somewhere in between that, and that is rising, right? So our text says the nation's population is trending older than it was 16 years ago, according to new U.S. Census Bureau population estimates released today. New detailed estimates show the nation's median age, the age where half of the population is younger and the other half is older, rose from 35.3 years on April 1st, 2000 to 37.9 years on July 1st, 2016. The baby boom generation is largely responsible for this trend, said Peter Borsella, a demographer in the population division. Baby boomers began turning 65 in 2011 and will continue to do so for many years to come. So we hear about generations, right? Boomers. So baby boomers are people that were born after World War II, right? They call them the boom because, when after World War II, you had soldiers coming back, you had people starting families. There was a big population spike in that generation. I'm the next generation. I'm Generation X. I was born in 1974. So that generation, late 1940s, I guess, into maybe the mid 1960s, or early 1960s, or maybe just into 1950s, right? That's your baby boomer generation, anybody born from that time. Residents age 65 and over, or senior citizens, grew from 35 million in 2000 to 49.2 million in 2016, accounting for 12.4% and 15.2% of the total population, respectively. So they accounted for, people 65 and over accounted for the 12.4% in 2000, 15.2% in 2016. So, that is that baby boomer generation that is larger than the generations that follow, right? And now, we're seeing some issues with that because we have an aging workforce that is retiring now. We're going to have, more people drawing benefits as they retire, right? There's going to be more people using Social Security, taking out their, retirement funds and stuff like that. And our workforce is not as large. So, a demographer, right? What they're talking about there is, demographics, people that deal with population data, right? Our census information. So the title here, we have the nation's median age continues to rise, right? And we have a map. Love maps. I have map background in geography. I look at maps a lot. So in 2000, it has county by county. If we're able to zoom in there, you can see the little tiny dots represents each county in the US. Some of those are really big when you get out west, and they're fairly smaller, here on the eastern side of the United States. And then our key, right, that has our information there, and the title there, 2000 median age in years by county, right? So they have it split up to 50, the age of 50 or greater. So that's that dark green. And then, 45 to 49, 40 to 44, 35 to 39, and then less than 35. And then the median age there at the year 2000 being 35.3. And we can look around that map and we see, there's some dark areas here and there, over sort of in Arizona and New Mexico, center of Texas, you see some dark green. Florida has an older population, largely because a lot of people retire and they go south, right? They're snowbirds. Maybe they own a home, in the north, and then in the winter they go south, so they're not in the cold. But you see, just small areas, and most of the rest of the country is in that lighter shade. There's not very many old people in Alaska, right? That's largely a light colored area. Same with Hawaii, right? But now 2016, we see a lot more dark green, right? We see 50 or greater. Lots of counties now are starting to turn that darker shade in Nevada, in Arizona and New Mexico, more in Texas. Florida's about the same. Up here in Nebraska, the Dakotas, Michigan, Wisconsin, Michigan over here, Wisconsin over here, Maine up here, right? A lot of an older population. So, just even flipping back and forth fairly quickly, right? You can see a significant change. You can see those dark green areas. And that's a great thing about maps. It's a great thing about geographical information is, which is something else that you'll see a lot, representing that information by location, right? By space and place. That's what maps do. At least, statistical maps, right? Showing you the areas where things are, you know, statistically different. So, right, even Alaska starting to get a little darker shades in there, I think. Yep, yep. So, look at our question then. So, does the included map support or contradict the information in the text? And sure enough, right, it supports that. The maps show that a large percent of all counties experienced increases in median age. Right? We can see that very, very easily, right? It's not something that you have to pull out a magnifying glass for. You flip between those two maps and you can see that. The median age, that middle ranged age, is going up.
Great job! You can see darker colors all across the map. The darker colors mean that the people living in those areas trend older. You'll notice there are a lot more darker areas in 2016 than there were in 2010. This indicates that the U.S. is growing older.
Yeah, and you know, just a caveat here, you know, there's you know, median age is one good statistic for that. But you know, if you wanted to explore it more deeply, if you wanted to challenge that, you know, there's other information out there. You would want to look at the range. You would want to look at the mode. What is the most occurring number in the U.S.? What age are, you know, pops up the most? Is it, you know, do you have more 48-year-olds than you have, you know, 35-year-olds or 72-year-olds? And you know, while that's the median age, you know, what's the average age? That's another, you know, those are not, you know, those will give you a full picture. Median age is a good way to look at it. And we can see more older people by median age, you know, in these areas. And the other thing too, you know, immigration is going to play a role in that. So, you know, that's a good baseline. And that's a strong, you know, evidence to support that. If you want to explore it more, if you wanted to question that, you would look at some other statistics. Okay, and
Very good work on those exercises. Now it's time to do some practice. You can show what you've learned and maybe learn even more.
all right, we know.
I have learning.
Okay, so yeah, let's go ahead. We're chugging right along here today. Let's take a look at the questions for today. There's, you know, there's several different passages. There's some text and some visual data. So let's do about 15 minutes again. And then we'll come back at about 15 here. So we'll say about, well, let's just go 10 after, because it's like 12:55. We'll say 10 after 1, and then we'll kind of go through the questions there and look at some of this data. All right, so let's go ahead and take a look, do some review here. So our first question right off the bat, all right, it asks us which of the following represents quantitative data, right? Quantitative data is going to have numerical values. Qualitative data shows you the quality of something, right? Senior citizen, that's a quality of an individual, right? Baby boomer, that's a quality of somebody. Residence, that's a quality of somebody. Median age, right? That's a calculation. So that is our quantitative data. And then I think it goes back to, yeah, so it's that same data. And I do, you know, wanted to mention, you know, even if somebody shows you a map, you want to make sure you understand that, you know, the credibility comes into play here as well. So we have information from the U.S. Census Bureau. that's about as credible as you get. And anybody can make a map. So and then it gives you the source of that, so you could actually copy and paste that information, and it would take you right to that map. So let's see here. It says, in what way do the graphics extend the data mentioned in the article? So the article establishes median age has increased. Maps show you where and how much, right? So that's what maps do. They're going to show you where the location of something is happening or where something is changing. Okay. All right. Article establishes that since more Americans are living longer, the median age of Americans is also rising. The map shows where the median age has risen, and using color coding gives a general idea of how much. Then how do the included maps support the article's claim? So comparing the census maps shows that the article is correct. Median age is increasing, right? If you had one map, it wouldn't do anything for you. If we showed it, if you gave you that 2016 map without comparing it to the 2000. So in this instance, you need two sets of data to look at to understand that. If you could represent that on a graph, it wouldn't show you county by county, but you could show, right, simply that the median age here in 2000, and you could do it year by year. You could have a graph that shows you every year up to 2016 and show that rate of change. All right, keep going here.
Excellent.
Yep, let's go on. And let's see, next one here. In what way does the graphic extend what the author is saying in this opinion piece? So this was interesting. So women and the wage gap, and different type of graphic, right? So it has, the key here, the dark purple circle is female median earnings, again, right? So what falls in the middle. Male median earnings is that sort of lighter purple type of color. And our sort of graph here, right? So from $25,000 up into the $100,000 area, and what that's denoting, right? So women are in the median income, right? That middle number, for example, for a payroll and timekeeping clerk is earning probably, it's between 25,000, 50,000. So we'll say around 40,000 or something like that. Whereas the men in that field, median age is making about 50,000. So that's how you read that graph, right? That little line, it's sort of arbitrary, but it's helping, showing the distance, right? The gap between the two. And there's some that are much closer, right? Licensed practical and, vocational nurses, that's fairly close. Pharmacists down here, it's fairly close. So we see high gaps like financial manager, where women are making maybe about 60,000, men are making 100,000 in that field. Insurance sales agents is a fairly large gap. Real estate brokers is a fairly large gap. Bakers, oddly enough, right? So there's not much gap in that field. And of course, the way this information, right, is presented. So they have it split by the number of, by the percent of gender in that role. So the 80% or more are female workers, right? And then 45 to 55% are female, and 80% or more male. So, a lot of the STEM type of jobs. And what the text was trying to point out was that the wage gap, what's really perpetuating the wage gap is the fact that women are not in those sort of STEM fields, and are in roles where those jobs generally pay less, right? That's where they're making an argument for the wage gap. So then, in what way does the graphic extend what the author is saying? So the graphic provides specific information about which jobs are dominated by what genders, right? It shows that. So that supports it. 80% of men or more in those fields like engineering and accounting and what have you. So yeah, the graphic provides specific information about which jobs are dominated by what gender, but you may have noticed something about that information, and we're gonna get a question about that here. So which of the following is a quantitative term, right? Quantity used in this opinion piece. So that would be median household income, right? Pink collar jobs, I've never heard that before, and that's a little bit, I don't care for that. Secretarial work, right? Just it's qualitative, tells you the quality of that work. Lower paying fields, also, there's no numerical value there. Median household income, right? That's going to be a calculated numerical value number. So it's median household income. What way does the graphic support the author's argument in this piece? So it shows that some jobs are dominated by a single gender and male jobs pay better, right? Now, there's also a contradiction here. The argument that the text is making is that largely the wage gap is caused by women working in other fields. However, there's a contradiction there because it's also showing, right? The graph shows wage gap exists regardless of whether or not women compete, right? So even in the fields dominated by women, men make more. So 80% or more female workers. Is that inverted? Do women make more? No, men still make more in those roles. Even these other jobs, right? That's the thing here. It's like, so, okay, even for pharmacists, even for financial managers, they're still making more, right? Women do work in those fields. Problem is that there's also a wage gap there between what people make. Something to point out about that though, right? We're talking about median. So if you wanted the full picture, what are you going to do? You're going to get the average pay between men and women. There's other things that also come into play here. Now, there's data to support the idea that women do get paid less in the same role. There's some jobs where women get paid more. And there's also, there is a large problem where women do not work in a lot of STEM fields. And there's been a big push to get more, young, girls in school to get interested in, math and science, engineering, in those fields. So the other problem here, when you're just looking at median, particularly in those jobs dominated by men, what level are these? Are these younger women who are starting in the field? So that's the other thing about wage gap. Do we have more men in senior positions at those levels, which would indicate that, right, that they're going to have a higher salary, more experience? Have they been working in that field longer? So it doesn't tell you everything, but certainly you're looking at a problem here because there does seem to be a wage gap between the fact that even women in those jobs are making less. So it does contradict the text to some degree. So the graphic shows wage gap exists regardless of whether or not women compete for male jobs. All right, and then the final one here. What way does the graphic clarify what the author is saying in this opinion piece? The graphic shows which jobs are gender preferred and what the wage gap is. I don't know if I like gender preferred. I don't know, necessarily that women are taking these jobs because they prefer them. But that's the language they're using there. But the graphic shows which jobs are gender preferred. I would say gender dominated would be a better term, right? Just because people are working that field doesn't mean they prefer that field. And what the wage gap is between and within them. So it does help to clarify it, but it could also contradict it if you wanted to come at that author with a different perspective. Okay.
Well, that's it for the lesson on bringing together text and visual data. Like I said, social studies topics can be pretty complicated.
Yeah, that's a really good lesson as far as like understanding, you have to look at everything there. People will use statistical data, graphic data, visual data, and it can also be manipulated. So, it's easier in text to see, like loaded language when somebody uses strong language to show you something or explain something, that could tip their hand to bias. But with statistical data, you have to be very detail oriented at what you're looking at. Make sure that it's matching up the claims that somebody is making, the argument they're making. And it really comes down to, understanding exactly what you're looking at, understanding the language that they're using, right? And a lot of that will be words like median, mean, range, and mode. So that's something else, to think about. Any questions on visual data, putting visual data and text together? Okay, so we'll go ahead, take a break till about 1:35, and we'll come back for language. We're going to do some grammar mechanics today, or it's going to be joining sentences. So that one's probably going to go pretty quick as well. So hopefully we'll get finished a little early today, and everybody can go, put their feet in some ice or something, cool off. All right, so let's take about a little over 10-minute break, 1:35, and I'll see you guys in language arts.